Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the inductive AC values from the Chapter 16 math handout, problem number 13. I will be getting my known values from the Chapter 16 math handout, problem number 13. I see here my total voltage, my frequency, and I will get my inductor values from the circuit picture. So we see here I've filled in my total voltage and my three inductive values that I was given. First thing I'm going to calculate is my total inductance using formula number 8. For a parallel inductive circuit, I will use the reciprocal formula to find total inductance. So it is 1 over under 40 times 10 to the negative third millihenries. Scroll over, plus 1 over under 160 times 10 to the negative third millihenries. Scroll over, hit plus 1 over under 32 times 10 to the negative third millihenries. Hit equals, hit engineering, and my total induction in this circuit is 16 millihenries. Inside of these parentheses here, I can use Ohm's law. On this particular circuit, I'm given my L values, and if I'm given my L values, I have to find my X values. And in order to find my X values, I will use formula number 14 from the Chapter 16 formula sheet. XL is equal to 2 pi FL. So I'm going to hit 2, shift, hit the exponent button for pi, times, I'm going to try to find XLT here, so it's going to be my frequency of 6.366 times 10 to the third kilohertz is my frequency, times my total induction of 16 times 10 to the negative third, 16 millihenries, equals 639.98 is my total inductive reactance. Next, I will find XL1. So I will take the formula 2 pi times frequency times, I will change the 16 millihenries to a 40 millihenries, giving me 1.6 k ohms. In order to find XL2, I'll use L2. So it's 2 pi times my frequency times, change the 40 to a 160 millihenries, giving me 6.4 k ohms. And to find XL3, I'll use the L3 value, 2 pi times my frequency times, we'll change the 160 to a 32 millihenries, giving me 1.28 k ohms. If I wanted to check my work, I would have to run these three values through this reciprocal formula to get this answer if I wanted to check my work for inductive reactance. All right, so now that I'm working inside the parentheses here, I can use Ohm's law to find ILT. Before I do that though, my rule for parallel shows me here that voltage stays the same in a parallel inductive circuit just like it does for a parallel resistive circuit. So I'm going to go ahead and fill in all my voltage values. They're all going to be 32 volts because voltage stays the same. Now I can find each one of my current values. So ILT will be equal to VLT divided by XLT. So I've got 32 volts over 639.98, giving me 50 milliamps. I'll change the 639.98 to a 1.6K, and that will give me 20 milliamps. I'll change the 1.6 to a 6.4K, giving me 5 milliamps. I'll change the 6.4 to a 1.28 K ohms, giving me 25 milliamps. So 25 plus 5 is 30, plus 20 is 50, so that checks out and adds up properly. Now that I have all of my values, I look and see what values I'm asked for here, and these will be the values that I will enter on the Chapter 16 Math Handout Canvas Answer Sheet assignment on your Canvas page. Thank you.